There we go. Not full screen. Now we'll draw it first. So particle. Actually, you know what? I don't actually need that on the table because I can just have it on my head. Can you see that? A particle travels in a straight line with constant acceleration f for 2. Oh no, yeah, A is the problem one. Yeah. Okay. The handwriting won't be great because I can't see obviously here. And then it starts off here with U, and it goes up here with F, and then this is for 2t seconds, and then covers 15 meters. Is that right?
Can we take this down then?
Do you want to write this down as we go along? Okay. I mean, I can send you this file too, but I think writing it down is a good idea as well. It goes across, and then down it goes. What's I can't quite see from here? Is the time in the middle 5t? Wasn't that it?
Yeah, 5t seconds.
So there to there was 2t, and then there to there 5t, and then the piece at the end was 2t. Oh, you don't know? Unknown. Okay. And what else do you know? 55 is in the middle.
Yeah.
Oh, and at the end is minus 3f.
And that the maximum is 32.
Oh, you know that the maximum here is 32?
Yeah.
So really the thing that's missing here is this thing here, which I'll call x. Oh, you had x equal to the maximum, didn't you? Or is that something else?
No, I had... Oh. I'm reading B.
Oh, right, okay.
Yeah, you don't know.
You don't know the maximum. Alright, okay. So I'll just call it V then. Alright, and have I got all the info on the screen here?
Yeah.
Okay. So, I should have drawn this smaller now. Well, you'll have it drawn there as well. Okay. So the first one we can say S equals U, which we don't know, T, which we do know, plus a half A T squared, 2T squared, which is 2UT plus 2FT squared. That's a 15. Yeah. That I can't really do anything else with that, so we can maybe park that. Now the next one is really just saying that 5t times v is 55. So 5t times v equals 55. I should really cancel by the 5, so tv equals 11. That's kind of nice, and I think you got that as well. This can let you change t to v or v to t, so that's good. And do we get anything for this last one here? Yeah.
Oh, I know what I have wrong.
You do?
Yeah.
What do you have wrong?
I had t over 11 equals v, but it's 11 over t.
Oh, is it just that? Oh. Well, let's continue and see what happens. So the one at the end, v equals u plus at. So v equals u plus a t. Or if you want, v equals 33f. Now, I'll put this bigger. So this equation here, we use what we want. But t, it's in terms of t, so we treat t as if we know it. So really the unknowns in this is u and f. Yeah? And here the unknown is v, and here the unknown is v and f. So this one here is actually the best one, because this one can really say v equals 11 over t. So now we treat it as if v is known. So this gives me v, and I can put, I feel like I should just put it into that one, shouldn't I? So that would be 11 over t equals 33f. So therefore, f is 11 over 33t. That's right, isn't it? And then we should plug that back into this one. So do you have this one written down? If you could read it out then. So what have you got? 15 equals
2ut
yeah,
plus 2ft squared
plus 2f
t squared.
okay, whoops, 33t, that's f t squared. Well, that's good, because then that t cancels that, so you get 50. Oh, it's looking much nicer now. 2ut plus 22 over 33. Oh, I'm sorry.
Yeah,
11 over.
thirds.
What am I thinking? Yeah, 11 over 33 is a third. I didn't cancel that earlier, so I should cancel it now. So it's 2/3. Yeah. T. So just go down a bit. You're looking for u, isn't it? So you can have. Should I take the t out? No. 15 minus 2/3 t equals 2ut. So then divide everything by t, I guess. Divide everything by 2t. So 15 over 2t equals 2 and t cancel. So actually, sorry, minus 1/3 equals u. Yeah, did I do that right? 2, divide everything by 2t. So 2, 2, and over 2. T, t, and over t. Yeah. Okay. Maybe we can write this as one fraction to make it look a little bit nicer. So then on the bottom we get 6t, and then we get 45 minus 2t. Yeah. Okay. And what's kind of nice about this answer is it doesn't make sense if t equals 0, which is good, because the question shouldn't make any sense if all of these pieces are 0. Alright. Right, so that's A. So we can, and we're happy with 1b, and we're happy with 2a and 2b. Would you like to see 3? Yeah, sure. Okay, so 3a now. I'll just turn the screen brightness down. It's a bit bright for me. Can you still see it? Oh,
yep.
A bit too dark maybe. Okay, so a particle's project. Oh, we kind of did A part, didn't we?
Yeah.
Do you want to see it again?
We can do the B.
We do the B part?
Yeah,
because that's the tricky part. Okay, a particle is projected at an angle of alpha to the horizontal, up a plane inclined at an angle theta to the horizontal. Okay, so here is theta. Now, that alpha is to the horizontal, so you have to be very careful here. You know what this is going, don't you?
Yeah.
This is going to be alpha minus theta. So the G goes down. This one is the G. Hang on, that's theta there, which makes that one theta there as well, isn't it? Yeah, it is, because that can't be theta, because then that, no. So that would be G cos theta, G sine theta. And the particle goes up, and then it hits the plane at right angles. But you know that, alpha is tan inverse 3.
Mm-hmm.
So you know that alpha is tan inverse 3. Okay. And what are we looking for? To show something, is it? Find the theta. Okay. So first, like always, we should try and find the time of flight. So that means I should try and break this up into its two parts. So we have the horizontal here, and we have the vertical here. So this one here is, now is u just u? Yeah, that's what you said, wasn't it? U cos alpha minus theta, and then the other one is u sine alpha minus theta. So time of flight, that's sy equals 0. So s, so that's u t minus a half a, which here is g cos theta, a half a t squared equals 0. U t minus a half a t squared. Yeah. So, well, you know the story here. The t's cancel. So you can rewrite this as 2u sine alpha minus theta. I can... yeah. 2 comes up, and then divide that by g cos theta. Yeah, that's it. Let's tidy that up. Okay, that's the time of flight. Now, what's special here is when it hits a plane at right angles, that actually translates into saying that Vx equals 0. So I'm going to see what that equation makes now. So Vx equals 0, so V, which is 0, equals u. Now that's going to be u cos, because it's the x one now. That's u cos alpha minus theta. So V is u t. I'll just write t for, no, sorry, don't do that. V is u plus at. So that's minus g sine theta t equal 0. I wrote 0 already there. Now I put in the t. So I have u cos alpha minus theta minus g sine theta with the t now, which is 2u sine alpha minus theta all over g cos theta, and that needs to equal 0. So far okay. Now because that needs to equal 0, I'll just take that over to the right, which means that must equal that. I guess this is the nice thing about the writing pad, is I can just cancel those g's now. Sine over cos can make a tan. I can cancel my u's on both sides. So I can bring this now, sine over cos is tan again, so I can get 1 equals 2 tan theta tan alpha minus theta then when I divide by cos. That feels like it's familiar, like I saw it in the question, but it's not. No. Oh, I tell you why it's familiar, because I remember sometimes they do questions very similar to this, and the question would say show this. So this year it didn't say show. You have to do a bit more. You have to get it and then solve it as well. Now this isn't too bad to solve actually, because you have a I'm actually going to bring the 2 over here to get rid of. You have a formula for tan alpha minus theta. It's tan alpha minus tan theta all over 1 plus tan alpha tan theta times tan theta needs to equal a half. And if we go back up to the top for a moment, we remember that alpha is tan inverse 3, which basically means tan alpha is 3. So I'm going to replace this tan alpha here with a 3, and I'm going to replace this tan alpha here with a 3. So I would get 3 tan theta minus tan squared theta equals a half plus 3 over 2 tan theta. Because, just multiplying the tan and bring that up to the right. So I get tan squared theta 3 over 2 minus 3 over 2 tan theta plus a half equals 0. Now we can multiply by the 2 to get rid of those fractions. 2, 3 and 1. So, well, we can try and get this ourselves. I know there must be 1s at the end because of the 1 here. And because there's a minus here, I know that these both must be minus. And I have a tan theta here and a tan theta here. And one of them must be a 2. Yeah, so there we go. 2 tan theta minus 1 and then tan theta minus 1. So that gives me 2 possible answers. Tan theta equals a half or tan theta equals 1. This means theta could be 45 degrees. And I don't recall, what's tan inverse a half in degrees?
29.5.
29.5. So they're the 2 possible angles then. Good, and I didn't even look at the question because you kind of just go in autopilot mode here, but is that what they were asking for, the two possible angles for theta?
Yeah.
To the nearest degree, so then that would be a 30. Okay, are you happy with that then?
Yep.
Right, so we're good with 1, 2, 3, so let's go on to the next page then. Now 4A is fine, and will we have a look at B then?
Yeah.
That was the bigger one. So can you put that there actually? Hand here. Just check the battery. So yeah. I'll just leave it like this so I can see when it warns me. Okay. A smooth wedge of mass 3m and slope alpha rests on a smooth horizontal surface. Well, that's good, at least it's smooth. A particle mass m is placed on the smooth inclined face of the wedge. It's released from rest. A horizontal force F is applied to the wedge to keep it from moving. Alright, so you can tell me if we're picturing the same thing. So you got your wedge and you got your block here. And this is a 3m and this is an m. And what's the alpha now? It's this here, is it? Is alpha. Yeah, and on a separate diagram, the force is acting on the wedge and on the particle. Okay, so this one here will have its downward gravity. I'm drawing it bigger than I need to. mg. This one here. No, wait, it said separate diagrams. Okay, I'll do it separately. So let me just remove this. So the first one, the 3m will feel the block pushing it in with R. It will also feel the table pushing up, which we'll call S, and it will also feel the gravity pulling it down, which is 3mg. And where does this F act? Is applied to the wedge, so there will be an F going this way, and that's all the forces that one feels. And then for the block, it's only really got 2. It will feel the wedge pushing back with R, and it will feel gravity pulling it down with mg. And if you like that,
can you just write or and or? Because I got confused
Oh,
with
absolutely.
the circle once. I had like an or and a q or something last week.
Yes. When one thing pushes against another,
Yeah,
the reaction, yeah, they're the same.
Yeah, see, I
Yeah.
wasn't sure.
There are too many variables then.
Yeah.
Yeah, it's the same for sure. Yeah. And if you like, you can break this up here as well into the two components. Now, if this is alpha, then it makes this one the alpha, which makes this one mg cos alpha, and this one here is mg sine alpha. And I haven't done it on this diagram. It's getting a bit cluttered, but you can do the same thing here to break it up. Now, if that's alpha there, then I think that makes this one the alpha here. Yeah, no, or is it this one?
No,
It's the other one, isn't it? Sorry, yeah. So it's this one here that's the alpha. Yeah, sorry, it is, isn't it? So then that makes that vertical one there or cos alpha, and then it makes this one here the or sine alpha. Yes, good. Now we might not need all of those, but just in case we do, they're ready there for us. Prove that the reaction between the wedge and the horizontal surface is that. Now what's a little bit different about this one compared to what we used to do is that it's not moving, which means there's no acceleration here. And that's actually a good thing. It makes it easier for us because it means all the forces must balance.
Yeah.
So when you look at, let's say, this one here, the forces going to the right would be or sine alpha. It's only that one, isn't it? And that must equal the forces going to the left, which is F. And then the forces going up, which is S, must equal the forces going down, which is 3mg plus or cos alpha. Now, what's actually, well, not weird, is that this force is only stopping this from sliding. This one will still slide down the surface because if you look at it, there is no upward force to cancel this one.
Yeah.
So in this diagram here, we can say or equals mg cos alpha. But now this one here is accelerating down. So now we should use our F equals ma. So that would be F equals ma, which will we take this one as positive? So then that would be mg sine alpha equals ma. So I've got 1, 2, and 3, and 4. Oops. Okay, and what one are we looking for? We are looking for the or, and the or in terms of alpha. Okay. So how can I put these three together to get what I want? Don't like the S there. Let's have a think about this. There's no F in it.
You could find the M in terms of or. Yes. Wait, why do I have an equal?
No, so yeah, that's a plus there. Oh, sorry. It's the reaction between the wedge and the horizontal surface, so it's the S we're looking for, not the or. Yeah, I was kind of a bit worried there. So the S. So yeah, look, we have S here. So I think we should replace the or with the formula up the top. The mg cos alpha going into that.
Yeah.
So we get S equals 3mg plus mg cos squared alpha. Oh, we're done. Mg bracket 3 plus cos squared alpha. That's what they want. Okay, so that's okay now?
Yeah. It's easier.
Doesn't seem so bad now, does it? Now, they say the speed of the particle after 1 second is 4.9.
Yeah, I tried doing this. I forgot what I did.
Well, u would equal 0.
No, it's only acceleration.
Good, okay, well that's great actually. So if you have that already, what did you get for the acceleration?
It could be wrong. So I was ahead.
Well, did you have this as u, t, and v?
I had V is 4.9.
Yeah, yeah.
U, T is
Yeah, so what did you get for a?
4.9.
Oh yeah, of course, because in one, yeah, 4.9. So I feel like it's just a matter of taking that number and putting it into, you see this one up here we haven't used yet. Oh, and the m's cancel there. So I get g sine alpha equals that number there. So g, oh, well, that's great actually, because g sine alpha equals 4.9. And I know when I divide by g, 4.9 over g is a half. So alpha is just sine inverse a half. Whatever that is, sine inverse a half. That's not one of the nice angles, is it? No, it, 1, 2, what's it?
3.333.
Oh, your calculator's in the wrong mode. It's in gradient mode instead of degree mode. So it's 30 degrees then. 30. Okay. Now, so that's 1, 2, 3, 4, and we're happy with those four.
Yeah.
Okay. So we have 5, 6, and 7. 5a, we can skip over that and just look at 5b. Okay. 5b then. These are the angle ones, aren't they? Okay. A smooth sphere P collides with an identical smooth sphere Q, which is at rest. The velocity of P before impact makes an angle alpha with the line of centers at impact. I don't know. True. The velocity P is deflected through an angle theta by the collision. The coefficient of restitution is that. So let me try and. Where's my little cursor gone? There it is. Okay. So we have our P and our Q. So the Q is at rest, so I'll just put the 0, 0 in like that. And then what's the P doing? It is the velocity P makes an angle alpha, but you're not actually told the speed. So we'll call it alpha. So that makes this one here V cos alpha. And that makes that one there V sine alpha. Is that okay? Now here's the trick in case you forgot it. The collision happens along the line of centers, which means in this case only the horizontal components change, which is good news for us because it means those vertical ones still stay the same, which is 0 and V sine alpha. These two change though, so I'll call it a P and I'll call it Q. And this is going horizontal now. This one previously, put in a dotted line here, had an angle of alpha. Now it has an angle of alpha plus theta. Because it says it's deflected by an angle theta, meaning it got changed by angle theta. Now, yeah, it'll go up. Alpha plus theta is the new angle. So we can apply conservation of momentum and we can apply restitution. I'm going to use the restitution formula first in the horizontal direction because that's the only one where the collision takes place. So you have minus E, and we know that is a third. So minus E equals Q minus P over 0 minus V cos alpha. Now also we can apply conservation momentum again in the horizontal because that's where the collision is taking place. Are they identical masses? I think they are, aren't they? Yeah. So we'll just call it M, which will end up cancelling. So we have V cos alpha plus 0 equals P plus Q. Now what I just did there was I took this one but wrote it as one line. This one here, there. So we have two equations, 1 and 2.
Add the minus.
Oh, minus,
Opposite,
yeah,
minus.
yeah. Now we treat P and Q like the X and the Y, the unknowns. So just to save time, because it's a simple task mathematically, I'll type these into our program and then solve for P and Q. So you have them written down, so if you can call them out to me. So the first one is going to be P plus Q, which is X plus Y equals
V cos.
V cos, I'll call it A instead of alpha. And then the second one?
Q minus P.
So that's Y minus X equals
A third V cos alpha.
which is like that. Solve system, two of them, line 1, line 2, x, y, solve. Alright, so x is 1/3 v cos alpha, sorry, p is 1/3 v cos alpha, and y is 2/3 v cos alpha. So I'll write that down here. P, what did I say, 1/3 v cos alpha, and Q is 2/3 v cos alpha. Right, now what I haven't used yet is the fact that this angle here is alpha plus theta. So the way these oblique angle ones work is that first you use restitution, then use momentum, and then you have to look at the angle after the collision, makes equation number 3. So you say tan alpha plus theta, that's the after collision angle. Tan is opposite over adjacent, which here would be v sine alpha over p. So here, v sine alpha over p. I'm just conscious the battery might go. I don't want all our effort to be lost. Oh, you don't mind turning around for a moment here? Yeah. Okay, I feel better now. Okay. Good. Okay. Now, I forget what we were looking for. Show that. Right, okay. Now, notice how we have P already.
Yeah.
It was 1/3
Cos.
cos v, so 1/3 v cos. That's great because the v's cancel. Sine over cos is tan, and 1/1/3 is 3. So I have 3 tan alpha. So I basically get tan alpha plus tan alpha plus theta is 3 tan alpha. And we just have to get it worked into this form here.
And that's just a
It's a trig formula, yeah, so let's see how quick we can do it. So this will be tan alpha plus tan theta all over 1 minus tan alpha tan theta equals 3 tan alpha. So we get tan alpha plus tan theta equals 3 tan alpha minus 3 tan squared alpha tan theta. So taking that over to the left, I'll get 3 tan squared alpha plus 1 tan theta. I took this over to be with that, and then take that over there, so that's 2 tan alpha because it's 3 tan alpha minus